Okay, so when we're looking at the change in amplitude to a graph, we're going to first look at how that affects the sine graph. All right, and it pretty much affects the amplitude of a cosine in much the same way. So we're going to look here at y equals a sine of x. So where a stands for the amplitude. All right, so if I'm looking at y equals 2 sine of x, then that means our amplitude will actually go up to 2 and will come all the way down to -2. So the zeros don't change. It's just here at the highest point it changes. So it's being vertically stretched here. So its low point and its high point are the only thing that's changing in the graph. So it comes up and then comes down farther and comes up, but it makes that motion in the same spot, so it's hitting back to 0 at the same time. It's just a larger radius, right? So if we look at this in terms of the unit circle again, right? So here would be a unit circle with a radius of 1. If the amplitude is 2 times that, then it would look something like this, where this radius is a 2. And so you're still going to get all the same points around here. It's just going to be higher. It's going to be longer. All right, so kind of understanding again how these graphs relate to the unit circle. Now you could also have a reflection, right? So let's look at here. Let's say this is y equals -2 of sine of x. Well, in that case, we're still going to start here at 0, 0, but instead of going up to 2, it's now going to go down to -2. And then before coming back up, and then before coming all the way up to here, and then back down. So all that does is reflect it. And instead of being positive, it's negative. Instead of being negative, it's positive. But doesn't really change much else in this graph, right? It just goes in a different direction. Again, instead of starting high or going up, it goes down. And so that's just a complete reflection when it's a negative in the front. All right? So that's the amplitude. Amplitude is the number in front, right? So this has an amplitude of -2. This has an amplitude of 2. We're talking about changing periods, right? Just remember that the period equals 2 pi over b, and that's for sine, cosine, cosecant, and secant. And then we can talk about the period of tangent equals pi over b. And cotangent is the same thing. All right. So if we were to, let's make this 2 pi. Well, let's just actually go back so it looks the same as all the rows. All right, so let's look at the function y equals sine of 2x. All right, now the 2 is the b, so I can say my period will equal 2 pi over 2, or pi. So from here, I need to complete my cycle. So I know that before, right, I had 2 pi, so I was breaking that up, right? So 2 pi divided by 4, I was counting by halves, right? Pi over 2, pi, 3 pi over 2, 2 pi. Well, now it's pi, so I'm going to divide that by 4. So I want pi over 4. So now I care about pi over 4, 2 pi over 4, which is pi over 2, and 3 pi over 4, and then pi. And then we could go again. We could say, what, this is 5 pi over 4, 6 pi over 4, which is 3 pi over 2, and then 7 pi over 4. And so again, we're going to start here at 0. Let's do our parent function. So it would reach our max height of 1 and our minimum of -1 here. Start here, go up to here. By pi it was at 0. By 3 pi over 2 it was here, and by 2 pi it was back to 0. So this is kind of our parent function here, what it should be doing. And let's take a look at what it's, if our period changes, it actually reaches its max height much quicker. And then it's hitting 0 here at the next interval, and then down to its minimum here, so that it's completing its full cycle of rising and then falling and then rising within 1. And then we know it's going to come back up to its max here, back down to 0, back to its minimum, back to here. And so we see 1, 2 full cycles within the normal 2 pi period, right? So we call that frequency. But that doesn't seem to be on the test. Frequency equals 2, period equals pi, right? 2 pi over 2, which is pi. And you're only divided by 4, so you know kind of where to find your points, right? And that's a change in period. All right, now we could also look at what happens to tangent, right? So let's get rid of this. Back to 2 pi, pi. All right, so again, let's look at tangent of x. All right, so here's the graph of y equals tangent of x. So let's switch it to y equals tangent of 2x. So again, our period for tangent is pi over b, which is pi over 2. Okay, so if our period is pi over 2, and remember that if we see between 0 to pi, right, there's an asymptote here halfway. So if we've cut that in half again, that means my asymptote should be halfway here and should be halfway here. So that's now, right, where my new function will be, right? So it's happening twice as much. Instead of every pi over 2, it's now happening every pi over 4. So pi over 4, pi over 2 would be a 0 now, right? So my graph looks something like this. It just shoots up a lot quicker, right? Okay, so let's look at some of this kind of combined together. The first example is number E, which is y equals 2 times the sine of 3x. So we have two things happening here. We have an amplitude change of 2, and we have a period change of 3. All right, so let's start with the amplitude. It now goes up to 2. So I'm just going to put a 2 here and a negative 2 here. And now think about my period. My period is 2 pi over 3, and that doesn't reduce. So what I'm going to do out here is just make this 2 pi over 3, and then halfway between that would be 2 pi over 6, or pi over 3, and halfway between that would be pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6. Alright, and if we wanted to go backwards, we can just do the same thing. We'll just call it negative 2 pi over 3. The middle here would be negative pi over 3. And then here we have negative 3 pi over 6, which is negative pi over 2, really. Right? Pi over 2. And pi over 6. Alright, so if I'm going to graph this, right? Again, it's a sine function, so it starts here at 0. Let's go back to our purple. Starts here at 0. By the first point, it's up to its highest point of 2. By the middle of its period, it's back down to 0. By the third quarter, it's down to negative 2. And by the fourth quarter, it's back to its original starting point of 0. And again, that's the sine function. You could go backwards. And it just looks like that. Alright, so let's try one more. And this one is y equals negative 3 cosine of 2x. So again, we're looking here at an amplitude change of 3 with the reflection, and a period change of 2. So let's make this a positive 3, and this a negative 3. And we'll think about the period of cosine is 2 pi over b, which is 2, or pi. So just throw pi here, pi over 2, divide that by 2, we get pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, and then we can go backwards. Negative pi, and this is cosine. So again, we're thinking it starts here. Normally it would start at the highest point and come down, but since it's been reflected, it'll start at the low point of negative 3. By its first quadrant, it gets to 0. When it gets to the next quadrant, it's at its maximum point, and then back to 0, and then back down to its lowest point. And we can just reverse those in the opposite direction to get the second half of this graph. And there is our cosine graph with its amplitude change and its period change. Alright? Okay, so if we're going to look at the tangent function of y equals tangent of 2x, right? There's no amplitude change, but there is a period change. And the period of tangent is pi over b, so pi over 2. Right? So again, if it's pi over 2, we should complete one full cycle. Instead of 2 pi, this would be pi. This would be pi over 2. This would be pi over 4. And 3 pi over 4. And we can go backwards. And as before, we had asymptotes. That doesn't was there. Now the asymptote would be pi over 4 and 3 pi over 4. Alright, so then we'll continue with the graph, which has zeros here and a 0 here.
That was a long time ago. It was fun. It was fun. I enjoyed it.
And that's the tangent function. Again, originally, right, this was 2 pi. This was pi. This was pi over 2. And this is 3 pi over 2. But because the period was divided by 2, all those points just get divided by 2. Pi over 2 divided by 2 is pi over 4. Right? Otherwise, it's exactly the same. So by switching these numbers the way you label the graph, you can change the period without really changing the look of the graph. So they should kind of look the same, and it makes it easier to graph that way. Alright, and then the last one we're going to look at here is we'll do one of the inverse trig functions, or not the inverse, but the reciprocal functions. We'll do y equals 3 times the secant of x. So again, you're thinking about the reciprocal of secant, which is cosine. So if I was to graph y equals 3 cosine of x, I know I have this is 3 and this is negative 3. Our period is 2 pi. Just throw all these on here. And again, cosine would start up here, come down to 0, down to its lowest, back up to 0, back up to its highest. Alright, and secant is the reciprocal of that, so wherever it's 0 would be asymptotes. Alright, so, and then we will touch off from there. There's that. We could go in the reverse order as well. So 2 pi, negative 2 pi, negative pi, pi over 2, negative 3 pi over 2. And just keep going up to there. So now we have the full graph, and we can continue then with our reciprocal function. We'd have it here, and we'd have it here. Okay. So we can finish this up to get that full U shape. So again, this looks just like the normal secant function, except that the amplitude is 3 and negative 3 instead of 1s and negative 1s, but it should look the same. And so graphing these reciprocal functions, it's always useful to graph the original function first in a dotted line, so then you can find your asymptotes where it reaches 0, and you can draw in your solid picture of your graph of the secant function, where it's touching at the highest point and the lowest point, and where it's approaching its asymptotes appropriately. So those are the graphs that you'll need. Try to practice the other ones. He provided an answer key, so you should be able to finish those off.